All right, welcome to our first episode of Very Good Engineering. Joanna, what a
Hi,
milestone, the first one.
thank you. Super excited to be here.
Yeah. I was really excited to do the first one with you because we're naming this Very Good Engineering. And I don't know if a lot of people know this, but you were actually the mastermind behind our Very Good Engineering site that contains all the best practices and standards that our team uses when working with Flutter. Let me know how did that start? Like, how did you get involved in that?
I think I asked you about that years ago, and we wanted to do something like that, and then it never really got like top of the stack of stuff to do. And then maybe a year or two later, I think you gave me the green light to do it because we had a really good reason to do it for the conference that was coming up. So that was a lot of fun, and it felt really good to do it. And I had learned a lot of stuff from building other personal websites and whatnot that I could apply and take that knowledge and build us essentially a static site to host that. So that's been a ton of fun.
I remember that we were we actually released that on FlutterCon New York. We had just like 2 months or something like that to do that, and I feel like the initial sentiment was like, "Ah, we're gonna make it," but like you powered through, you rallied with the team, and look at that, you did it.
Yeah, they did a really good job. I basically had to beg and plead to get everyone's time, like, oh, please stop what you're doing and write some documentation and help me with these demos because we were trying to bring a bunch of stuff up to speed, and so everybody really pulled through on that, and that was super fun.
Nice, nice. Well, I thought it was just a great way to pay homage to you by saying like, "Hey, you kick off very good engineering both on the website and both on the YouTube series." So, what we're going to be covering today, and this is also very exciting because you're very prolific, right? Is that recently you announced like a pet project that you had that, like, I don't know if it's going to be, I mean, it's literally the idea of a pet project because it's named Cow, right? But before we get into Cow, how you built it and what that is, I don't know if a lot of people from the Flutter community know that you're actually heavily involved in another community as well that is with Godot, right? Like it's a open source game engine built in C Sharp, and you run your Soft community. Tell us a little bit about that because I think that that's a side of you that a lot of people in the Godot community might know, but not a lot of people in the Flutter community might know. So, what is Godot? What is Soft?
Yeah, so Godot is like a an open source game engine that's, it's built in C++. Flutter is also built like a game engine. So when you start thinking about these two things, they have a lot in common. They're both heavily tree based. In fact, Godot is kind of modern in the sense of how tree based it is. So it's a different paradigm than working in Unity a little bit or even Unreal. And so because of that, like Godot and Flutter, like if you know one, it's not too hard to pick up the other. One's just a little bit more imperative and the other is a little bit more declarative, and that's mainly for performance reasons. So it's really neat. And then a couple of years ago, I started using Godot to get back into video game development, which has been like a long running off and on hobby for me. And I started using it with C Sharp, which, is like an elder cousin to Dart, the programming language, along with Java. So they're all very similar. And so it was the natural choice for me. And so I started using it and I thought, wow, this is like oddly good. And nobody's really talking about it, at least with C Sharp specifically. And so I started, talking about it and making friends in that community as well. We didn't really, there was just like one little channel to talk about C sharp in some of the popular or the one popular Godot Discord at the time. And so if somebody else was having a conversation, you would feel really rude for kind of bumping in and saying, hey, what about this other thing? And so I made some friends from hanging out in there a little bit. I would try and just working on fun little projects. And I realized we needed more space to spread out and breathe and talk about C sharp specifically with Godot. And so I had created this other Discord server, Chickensoft, which was sitting empty. It was just for me and my friend to talk about our little game development project, but it had long since been abandoned. So I just kind of repurposed it and invited all the people from the Godot C sharp world to join it. And then it started, it was like 30 people for a long time.
Mhm.
That was like about the extent of us. It was this tiny community. And then I wrote this blog article called "It's Time to Make That Indie C Sharp Game in Godot."
You
And
got
I think
some
I
potential,
posted that
right?
here at work. Do you remember that?
Yeah, yeah, I do.
And that was kind of fun because I posted on Hacker News, and that's like the only thing I've ever posted on Hacker News that actually got any upvotes, and it got a lot. And it had its little moment of time in the spotlight, and that got chickens off to like the first 100 people. And so that was really the first big growth injection, and that created kind of the grassroots Godot C# community that it has grown into today. So I've been pushing out tools and helping people in that community as best as I can for the last couple of years for fun, and that's been really great. And then lately I've been toying around with doing stuff in Dart for fun as well. So yeah, that's kind of the short story of that, I guess.
Nice. And I mean, I know that you could be talking for hours and I could be listening for hours. So maybe we'll reserve that for another episode. But I think, correct me if I'm wrong, that you've brought a lot of ideas and inspiration, even from the work that you've been doing with Flutter and Dart, whether it's
Uh-huh.
State Machine back to Godot, but also probably ideas from Godot back to Flutter and Dart as well, right?
Yeah, actually, that's a really good way to put it. For years, I was porting things that I learned from Dart and Flutter to Godot because I would sit down, and of course, working here all these years, you would sit down, I would just expect a certain quality, like a certain bar of developer tooling. It's like, oh, where's provider? There's no provider. So I had to build that equivalent, but you have to build it differently because it's a game engine and performance is different. So it's the same idea, but it has to have different performance characteristics. And you sit down, you're like, how do I update Godot easily? There's no installation tool. What about managing add-ons? So like all this, like pub, like how do I add a package easily? And it's just like those tools were they're kind of there, but they're not what I expected the quality to be. So I started just building these things, going, how can anyone live without this? But that was because my standards were so high from working at VGV.
Yeah. I'm very curious because at BGB, like we've done like a decent amount of games, but not everyone in the team has had the chance to work on gaming. We've used Flame a lot. We actually have in the team folks like Eddie Sanarda that they're like main maintainers of Flame. What is the change in mindset that you need from working on apps to working in games?
If I ever figure it out, I'll let you know. But there is some like kind of wisdom. So like the cultures are wildly different.
Mhm.
If you talk to people who are professional game developers, engineering quality is not even on the radar. It's the only time that's on the radar is when you got to publish and you got to get performance just barely good enough. So culturally, it's very different. You start to see this change a little bit with newer indie devs coming in that already have, industry experience doing, regular apps and whatnot. So the indie crowd, there's a subset of them that actually care about nice engineering and whatnot and level of quality. But games historically has just been get it done, make it work, whatever works. And it's because a game just if you go and just make a video game, there's no guarantee that it'll be fun. No one really knows what makes it fun. And so the idea is that you just keep refactoring and making prototypes until it starts to feel good. And by then your code's a mess.
I had the privilege of building a very, very small game with you for Google Cloud Next a couple of years ago. And that was also like a personal challenge of mine. It's like, can I do this when like I've never done a video game? And the first thing that kind of like you need to adjust is like you have a loop that is running consistently. So you paint the proper like frames on the screen. And that changes everything. And then like collisions, all of a sudden, like you have to brush off all the math that you learn in high school and college. It's like, oh, trigonometry finally makes sense. Although when it got really hard, like I asked you to do that part. So thank you for, for that.
I remember complaining about that too. I was like, how come Flame doesn't have that forward collision detection that I need? And I had to kind of implement this algorithm. And I was like, I don't have to do this in other engines, but I gave Eric a hard time about that. I think it's getting better actually as far as that kind of integration goes. But that was kind of fun challenge. But yeah, that was a little bit more of a challenge than it should be.
Awesome. All right, we're going to switch gears a little bit because the main topic of today is actually cow. And I'm starting to realize that you have a thing for like pet projects that are pet based because you have your chicken soft, you work in Flutter, and we have Dash, and all of the sudden you released Cow. That the tagline is a humble AI for your computer. What is Cow and why did you build Cow?
So I do like the barnyard animals. So chickens, now cows. And The reason I built it was because I had aspirations prior to building it that got beaten out of me while building it because it turned out to be really hard. So all the reasons I wanted to build it just became, oh, can I build it? So the idea originally was like ChatGPT, Claude, these are getting expensive hobbies. I use them extensively for personal stuff, and wow, it adds up. And I really like that ChatGPT is better than Google. I'll ask it to figure out something, and it'll be like, "Here, I just read 60 articles." It's like Google just doesn't do that. It's the history of the Google algorithm has changed over time in like a lot of different ways at different milestones. And I was like looking into that and prepping for this. But ChatGPT is just superior for finding information about complex topics. So I really liked that. And I wanted to build my own local version that could Google things for me. I did not get that far because just building any kind of local agent running a local AI turns out that it has like just tons of challenges. And so then it just became oh, can I even do this at all? And then it was just all this effort was going into engineering this little Dart project to run a local AI.
So to help people to understand, and I know that we're gonna get into visuals in a demo. Is this like it's a local agent that runs on your computer and you've built the interface on top of that? Am I understanding that correctly?
Yeah, so basically it's kind of like Claude Code or Codex. You type in the name cow, up comes this terminal interface, and you can chat with an AI that is running locally on your computer, and it will tell you whatever it knows, which is not much because it's running off a local model, but it does its best. And I think that fits the name cow as well because you don't expect it to be super brilliant.
Well, I mean, I think that there might be a world, like maybe we're not there today, but like I think that like local models, right? They're gonna have a lot of like features, especially like specialized models that maybe you train somewhere else and then bring it down to like local environments, things like that. Those are gonna be great for like energy consumption, for like fast, quick decisions. Like you don't need to know the whole internet all at once to get through those spaces. Now let me ask you, how did you build it? Like what technology did you use? Like
So I built it in Dart, just vanilla Dart. I found this terminal user interface library called Nocturne, which is built by somebody named Norbert, who's
mhm,
kind of a big deal.
yeah, good
And
friend of us.
do what?
A good friend of like the Flutter community.
Yeah, yeah. And I wasn't like super familiar with him, but it was cool to see that this was his project because I had seen him for other stuff. And so I started using this library and I was like, wow, this is really terrific. It's just like using Flutter, but for the terminal. And so I thought that was really neat. So I broke out a block to use as my state management, and I was like, oh, wait a second, this isn't actually Flutter, so block isn't hooked up to Nocturne. So I had to build like the block provider equivalent and block builder equivalent for Nocturne, which I mostly just pawned off to Claude Code to build that for me. So I ended up building the block integration for this UI system, and then I could use that, and we'll get into all that. But basically, I found all these libraries that I needed to make Dart work, and then I had to hook up the LLM, so I had to like hook it up to this project called llama.cpp, which a lot of local model runtimes use as their backend.
So you had to get into like even like bindings and things like that.
Yep, a lot of native binding generation. The packages that existed didn't actually work. They weren't up to date. So there's problem after problem.
All right. I think we've given enough hints to the people that like maybe this is a good time to do a quick demo.
All right, let's see what I can.
Yeah, I say that while you load up the environment, I heard about Nocturne for the first time as I was preparing to talk to you for this episode. And as soon as I saw it, I was like, this is really cool. And like it's not that often said that you can build really complex CLIs with Dart. I think that people are thinking like, oh, Dart and Flutter, they go hand by hand. But like now we're starting to see like Dart to become very popular in non-Flutter environments. Like, of course, like there's like backend projects these days, like Serverpod, like Dartfrog, things like that, that is becoming very popular. But like, actually, I'm starting to hear a lot of people that they've decided like, I'm not gonna build any more like bash scripts or anything like that. Everything's gonna be Dart, one single like you can turn it into an executable, into a runtime script and all that stuff. So it's trying to show its power one kind of like project at a time.
I think that's really interesting because like Dart is really useful because it compiles right to native and it's very friendly because it's a garbage collected language and all that. So I definitely like that I can keep everything in the same language for scripts and whatnot. And I think actually I have a script somewhere in here that actually is responsible, or I did have a script that was responsible for like helping me build the project and whatnot. So that was actually super cool. And I think I used it to get the native libraries for the Llama CPP project. Um, but I'll hold off on that. So moving on to like actual demo. So basically, you can just run the command dart run bin/cow.dart once you've cloned it locally here, and it's going to take a second to load its models, and then it's going to run. So I'll make this a little bit bigger. As you can see, this is the cow interface. You have the cow in the bottom right corner. This is where it thinks.
I gotta admit that I'm a sucker for ASCII art, so thank you for having that.
Interestingly enough, I had to do the ASCII art by hand. I did try to be lazy for a second. I was like, Claude, make me an ASCII cow, and I just got like gibberish symbols back. So it tried. So what I did is I went and looked at this repository of over 400 cow ASCII art drawings, and I kind of studied the literature, and I was like, okay, I can draw a cow now, and I kind of made my own variation of it, and that's how I got this cow.
Oh my god.
And it's because there's this Linux app that's been around for a long time called Cowsay, and you
Mhm.
can use it to just make a cow say whatever you want in the terminal. And so this is obviously named for that program.
I
It's a,
was
I'm sorry.
oh, no, I was just gonna say that, I mean, the logo is not the most important thing, but it's probably the cutest part of the project. And when I was loading it up on my computer the other day, my kid saw it and he was like, "Papa, why do you have a cow in your computer? Like, how do we go from there to explain? Like, I'm doing professional stuff, like sometimes you can't just like, well, I don't know, buddy, my job is fun. What can I say?"
That makes me super happy.
Yeah.
I'm also happy that this reads as a cow, so that's cool. So cow is kind of interesting because I can say, what does it mean to be alive? And Cal really likes to overthink, so it's gonna sit here and really think about it. And I'm sharing my screen, and I've got
Mhm.
multiple monitors going, so my GPU is already taxed, which makes these models run even slower. So you can just see Cal kind of anxiously worrying about philosophy. And while it's thinking, the summary is coming in and being summarized by a different model that's running on the CPU. And that's how I can run two models at once. And now it's giving me its actual answer, and the summary model is, I guess, still summarizing.
When we talk about local models here, and this is important because I think there's a lot of companies these days thinking about like, okay, when I use LLMs, AI, where does my information live and all the stuff? All this is happening in your computer, not going outside to the network or hitting an API and coming back. Like all the information stays with you and your walled garden, right?
That's correct. So what's happened is the moment you run cow, the first time you run it, actually you'll see the screen where it starts downloading about 8 GB worth of GGUF files, which are the weights of an AI model. In this case, Cow is just kind of hard coded to use Quinn 3 as the main model. I think it's using an 8-bit quant of that, if for all you machine learning people. And then for the smaller model that summarizes the reasoning output of the bigger model, it's using Quinn 2 or 2.5, the 3B one. I think I'm saying that right. I'm not a machine learning guru, but basically these are pretty tiny models that can run on just about anyone's MacBook. So that's what it's doing. And then once those models are loaded into memory, which is what it did a second ago when I opened it, and I'll do it again here. But once those models are loaded into memory, then you can do what's called inference, where you can essentially talk to them. And you saw it just flicker there for a second where it was loading both of them. Um, Interestingly enough, actually, inference has to happen in its own thread if you want your UI to be responsive. So that means you've got to use Dart isolates and whatnot to kind of make that happen as well. So that was another like layer of complexity. I was like, oh, my UI is hanging up because running a local AI model is actually really intensive.
Yeah. Well, I mean, you were looking for an engineering talent, and you're pretty much utilizing every single aspect of Dart.
Yep. Yeah, it just kind of turned one thing into another. So that's what Cal does. It can also call tools. So I can just say, I can turn off thinking for a second, and I can just say, what time is it? And it will hopefully, yep, invoke the date time tool, which is the only tool I've given it. And then it'll tell it right back to me. It can do that with reasoning on as well. It's just sadly pathetic how much it has to think about it, calling a tool before it calls a tool.
It's funny when you ask for the date, it takes 30 seconds and gets it wrong, but that's a different story.
Yeah. In fact, someone responded to my tweet, I think, on Blue Sky and said, it seems like it'd be faster to just look at the clock. And I thought that was really funny. And it's still thinking about calling this tool, which
You
is
know,
really funny.
whoever said that wasn't thinking as an engineer.
I think they were just pulling my leg.
Yeah.
It was super funny.
So I have one question because, of course, like the user interface that we're looking at here, it's all like terminal based, but it's very complex. Is this like the part that Nocturne was fulfilling for the project?
That is correct. Yeah. So Nocturne provides a lot of widgets for your terminal, and it looks just like Flutter code. So um, it finally called the date time tool. Uh, Nocturne provides all these widgets, and you kick off your app, with your main function.
Mhm.
You send it to run cow app, which is here in my source code. And then similar to our other Flutter apps, we do all the guarding, and then you just kick off to Nocturne's run app method, and that will start your terminal UI app just like a Flutter app. And then you can do whatever you want with widgets. Nocturne has all the common stuff you would expect. Although Nocturne is kind of early in development, I actually had to contribute a bunch of fixes and features to it to get it to do everything that I needed it to do. So that was actually kind of fun to learn about it. And Norbert was great to help me get those in as well. So once you run your app, it looks a lot like just a standard Flutter widget, but instead of widget, you see the word component everywhere. But
Nice.
as you can tell, it's exactly the same thing.
Nice. Hey, this is one of the beauties. Like when I started like learning Dart, one common saying was that if you know JavaScript or if you know Java or if you know C Sharp or whatever, congratulations, you know Dart. But I think one of the powerful things these days, given like the widget system and how strong that API and like the composition has been, is that you start to see the paradigm being applied in a lot of places. Like you see like with Nocturne, you see it, for example, with Jaspr, this kind of like new site generator that is being built with Dart. It's like that idea of like components, widgets, how compose them and all the stuff. It's pretty much like the same thing. So you can now pour your knowledge, of course, apply it to different platforms and whatnot. So there's an element of familiarity that becomes very, very important.
Yeah, exactly. I obviously was able to just be like, oh, I feel right at home here, and that's one reason I picked Nocturne as well, because it so closely mimicked Flutter, and knowing that paradigm is really nice. Um, I guess, and the same is true because like React is ending up everywhere as
Mhm.
well. So those paradigms are similar and also useful to just kind of know.
Cool. All right. So this looks like Flutter, but it's not. It's Nocturne. I'm seeing like block provider and startup qubits and all the stuff. But that didn't exist for Nocturne, right?
No, this did not. So if we scroll down here over here on the side, you can see this packages folder, and I had to create all these supporting packages just to make Cal possible.
Nice.
So one of these is block term, which is what I called the package to hook up block to Nocturne.
Uh-huh.
And so this is obviously available on the Cal repository to anyone who needs it. I didn't publish these as separate packages. I may get around to that. But if you look at it, here's the source code for a block builder adapted for Nocturne, and it looks pretty similar overall,
Very
actually.
familiar. Yes.
Yeah. I had to make a little provider stub that's like way simpler than like the actual provider, but I just needed to be able to provide things. So that was kind of funny. And then I have a block provider that lets me get a block. And that was like I thought at this point, okay, I'm done with state management. And then I can come over here to where we run the app and be like, oops, not that. I thought I can provide my app info, and then I can run my cow app, and then in here I can provide my startup qubit, for the overall logic and stuff. And that did solve that problem for a hot second. But then the blocks for my actual user interface experience ended up getting really complex. So I had to come up with some more ways to organize state management. And that turned into a whole nother thing. But this got me really far for a while in development.
Nice. Um, can we jump into the part where you connect with the local LLMs? Because I think that part might be really scary for a lot of people getting into AI and this idea of like, I'm even just like getting used to or like started with like the cloud APIs for Claude or like a Codex or like a ChatGPT or whatever. And that might be intimidating. What was the work required there?
It was pretty intimidating. And if I hadn't been leveraging so much Codex and Claude Code, I would still be working on this because you have to build like this entire mountain of stuff to even just be able to talk to an AI for a split second. And so I didn't actually realize just how bad it was. I thought these were solved problems for Dart, and they just kind of weren't, because most all of the tooling is designed to hook up to servers, which makes sense because that's where the frontier models are and where most of the value is. But you kind of need a lot of really abstract things. Like you need a high-level agentic loop that can take data that's streaming in from an LLM actively and then kind of decide, do I want to call a tool? Is this reasoning output or is this the final answer? When does the final answer start and all this stuff? But then to do that, you now need to like host a thread that's running, that's wrapping around Llama's CPP bindings. And then you have all this in between logic that needs to happen between the native layer and your high level agentic loop. And it just gets more complicated from there. But basically, we'll start, I guess, from
I have a
the easy
question
way in.
because I wonder if someone, as they're kind of like watching this video, they might be wondering if this is a terminal application like a CLI, what is the native layer? Because I think a lot of people, when they think of like Dart and Flutter and they apply it to mobile, it's like, oh, the native layer is whatever I have on Android or in iOS or Mac OS. But in this case, when we talk about the native hookups, what are we talking about?
Yeah, that's a good call out. And I probably shouldn't call it that because technically Dart is native, kind of, sort of. So I guess a better way to word it is we are hosting or rather, we're hooking into dynamically linked libraries, which on Mac is a dylib or a SO file on Linux or a DLL on Windows. And so we're hosting Llama CPP as a suite of DLLs or dylibs in this case, and loading those up and calling methods in those. And I was kind of calling that the native layer, but that's kind of, like you said, a weird term for that.
Like naming things is hard. I'm not even an English speaker, so I totally got what you were saying. I was
Uh-huh.
just thinking, like, if someone is thinking of native, are they thinking like, oh, do I need a different thing for whatever, right? So I'm glad that you clarified that. Thank you.
Exactly. It's confusing. Um, if you look here, this is we create the qubit for managing the chat experience in our chat page. And it looks pretty straightforward, but there's a lot of pieces that go into it. We have this really high level object called Cowbrains, and it lets you create multiple like a single Cowbrain, and you can have as many as you want. And each Cowbrain runs in its own isolate so
Uh-huh.
that you can interact with it without stuttering. And so Cowbrains helps you manage those because you have to do some initialization with Llama CPP at the start and at the end. So Cowbrains kind of tracks how many brains you have and when they're all alive and when they go away and stuff. And then you want to be able to create a brain. In our case, we use two different brains. We have the primary brain used for generating answers and thinking, and we have the lightweight brain, which is used to summarize the output of the reasoning of the primary brain. And that's actually what like OpenAI and Anthropic do when you are talking to ChatGPT and it's sitting there thinking and you're looking at what it's thinking. It's using another model to summarize the output of a larger model. And Anthropic does the same thing. They use Haiku a lot for the lighter weight tasks and whatnot. And then you get into subagents, stuff like that. It's a similar idea. Um, and then I create, various auxiliary tools that I need, such as, in this case, I'm using state machines to track the complex chat state because there's a lot of different things that can happen while you're chatting. It all runs kind of concurrently. So I use a number of state machines to help with that. And then I have a tool executor so that you can give the system all the registered tools, which in this case is just the date and time. But I tell it that, and then I spin up my chat cubit, and it has a lot of dependencies because it has to be able to interact with these systems, and then let it go from there. And then from there, it's just a UI, and it looks pretty typical, although you do have to handle key events in a kind of interesting
Yeah,
kind of
because
way.
you're listening for keyboard events, like
Right.
everything from thinking to execute and all those things, right? I have a question because one of the things that like you've mentioned a few times, and I want to make sure that it's well understood, is this idea of tools, right? Is that like a way to extend your local model with particular knowledge? Like, I don't want to call it skills because blah blah blah. You know what skills are these days. But like when you work, for example, with things like LangChain and all the stuff, like you can give particular powers to your model. Is this the same concept?
I think so, although I'm not super in the know with LangChain.
Gotcha.
But basically, yeah, when you are talking to Claude Code and it reads a file, it's using a tool, so to speak. A tool is like a built-in skill because skills are kind of the hot new thing, and they just kind of let anyone hook up a capability to an AI agent. But a tool is like the same thing, but it's something that you, as the programmer, have built into your agentic loop, so to speak, like your high level integration with an AI. And so in my case, I provide a tool natively, so to speak, to the AI and say you can get the date time whenever you want. And I set that tool up here in my app info that's provided at the top of the app. And I have tool definitions. It has a name. It tells the AI what it can do, and then it tells the AI if it needs any parameters, which of course it doesn't because it just gets you the current time and it'll run this little closure whenever the AI decides to get the time.
And that's really cool.
Yeah, so I guess that's to kind of explain tools at a high level. It really is that simple. Is basically you give the AI a bunch of callbacks and tell it what parameters you need for each one and what it can do, and it'll decide if it wants to use it. It can get more complex than that, I hear, but I haven't worked on the projects where it's gotten more complex, so I can only speculate. um, the most of the complexity for cow lives in this package called Cowbrain,
Mhm.
accordingly. And if you look at the README for Cowbrain, you'll see that it's got a lot going on.
Yeah. By the way, I encourage everyone to look at the different readmes that they will find in this project because not only you explain it really well, you apply humor in a very nice way. Let me tell you, I've seen like tiny jokes around here, like put the computer out of pasture, or like careful, you're gonna end up in an stampede. And I'm like, this is so Joanna. I can just see your brain working through those jokes. So I really appreciate it when like things get so heavy and dense.
Thank you. It was a lot of fun. Like, obviously, I learned a ton doing this. And so, yeah, you got to joke about it, I think. Cowbrain's got a lot going on. This is where most of the AI hookup stuff happens. Cowbrain actually depends on this other package called Llama CPP Dart. Um, I tried to use someone else's bindings, but they were way out of date, so I had to make an FFI generator project.
So that's your binding layer.
Yep, and do that. And so it's very boring, but it gets the job done. Um, and it, has a build hook and it handles the native libraries for each platform and whatnot. So there's a lot going on with that, but it's not very fun stuff. Cowbrain though is where the fun stuff happens because it can use the Llama CPP bindings and turn that into a higher level workflow that's actually useful and let you talk to multiple AIs, multi-threaded, running locally. And I just don't think there's anything out there for Dart today that can do that. So if you need to do that, we know how to do that now, and you can look at Cow as a reference. Um,
If I ever need to do that, I'm calling you.
I would be disappointed if you didn't, because I spent all this time learning, and it would be so redundant if you had to do it all by yourself. I would be happy to help. So basically, yeah, you've got your client app, and then you have your Cowbrains, and then the Cowbrain has a brain harness, and that spins up a thread for you, and then because because Dart does threads kind of in a very rigorous way, you can't just call a method in a thread. You have to send it a message through it through what Dart calls it as an isolate, and it makes multi-threaded a little bit nicer in the sense that it's very rigorous, but it also creates this huge amount of boilerplate because now you need to serialize all of your requests from one thread to another, and now you need models that can serialize JSON or whatever you want. And I picked JSON because it's simple. And so I have all these models for all these agentic requests you can make, and then it serializes them, sends them to the thread deserializes it, and so on. So that's what happens here at this isolate boundary. You get your JSON data. It handles the message. It can do a bunch of different things, like start a turn, like a chat turn where one person's speaking and whatnot. And then it has an agent loop, and it has a understanding of the conversation. It has this sliding window context manager. It's got the tool registry that you have defined for it that gets reconstructed from serialization. It actually has to send messages back out and say, oh, the AI has requested a tool, and that gets serialized into a message, and then your app has to deserialize that, and well, actually Cowbrains does that for you. And then you get that event back, and then you're like, okay, now I can actually call the tool. Okay, this is a tool set, I'll pass it back as a tool result event. So it just ends up creating a ton of boilerplate, but that's kind of what you have to do if you want to play ball with the big dogs, because that's kind of how these apps are structured. There's just no easy way to do that. And then you have getting lower level, the agent loop is using something called a LLM adapter, which is using these specialized tools like the universal stream parser and the various templates, because each AI model needs a different template format. So the strings, the tokens have to be exact. Certain models expect tokens for a start of turn sequence, and then an end of turn or like a tool calls have to be formatted as text in a very specific way. And each model's different. And so we kind of have support here for the Quinn-based models that are using like chat ML format to some extent. So that's kind of built in, but I haven't like built equivalent ones because other local models don't support tool calls as well. So there's really no reason to support them yet. So all that aside, the LLM adapter is handling that by using these other specialized tools. And then it can then, count the tokens and then pass that off to the actual Llama client, which is talking to Llama CPP on behalf with the generated bindings. So that's kind of a high level overview of
Just surface
what's
level.
happening. Do what?
Just surface level.
Just surface level. And there are some fun things like in Cowbrain specifically. Like if I want to show some actual code, I think if you go to one of these, I think agent loop is where a lot of interesting things happen because it's more abstract. It's built off of all that other stuff I just covered. So at run turn, produces a stream of events, agent events. And it takes all these things and it kind of has all of this insane, steps, like you have to prepare the context, and that's because you don't really want to toss your context right away and rebuild it every request if you don't have to, because that can actually be kind of intensive. And so it will only rebuild the context if you have to, which will happen if you toggle tool use, because that actually changes something in the prompt way up at the top of the prompt. It's just how the models want it to be formatted. So in that case, it'll rebuild the context every time you press Shift Tab, but otherwise it's trying to preserve it as much as possible. And then, it's going to sit here and produce the relevant agent events. And every time the agent comes back with more data, it's going to produce a telemetry event so you can see how much context is being used up in real time and things like that. So this agent loop file is kind of interesting because you get a feel for all of the different lower level events that are getting translated into things that are useful to your app.
This is all to say that whatever people think, building a chat application is not that easy.
Yeah, it's incredibly, incredibly advanced if you're bootstrapping the AI yourself, I think. And even if you're hooking up to like a server model, there's just a ton of state involved.
Yeah. And optimizations. I think that we know that at least in the world that we live in February of 2026, right, tokens, context preservation, all those things are like where like a lot of the cost is right now. So how you optimize, slice it, tokenize, blah blah blah, gets very important. Maybe years from now on it will be a different story, but a lot of the complexity and smart operations today probably are in that area where like the other side is just the presentation layer that can get very complex. And I'm sure that we're gonna see improvements in that area, right? Even just through a terminal, like is there a generative user interface for terminals? Like it can get wild uh very very fast, but right now like there's a lot of kind of like things behind the scene to make sure that we only pass to the models what they need at that moment to be effective.
Right. And I think there's probably, like, as we speak, there's probably a ton of companies building these tools to make it easier. Um, so I think, we won't have to always do this step. I think it's because I picked to do local models that I ended up in this pickle. So here I've cleared out Cal's cache so it thinks it's running for the first time, and I did that by deleting my .cal folder in my user folder. So it's now loading these models, and this is what it does the first time you run it. I just kind of want to demonstrate that. But while it's doing that, one of the big problems I had while working on this, because I was using a lot of Claude Code to create this app, because again, the scope is massive. It would have taken me a good year of free time probably otherwise to do it all by hand, um, especially given how much learning was involved. And so one of the things that was tough was the state management for the chat experience. Um, what was interesting about that is that your chat state is streaming from multiple sources at the same time, so it's a kind of a stream combination problem. But then you don't want to block the UI at all, and you want to know which state you're actually in, and streaming can sometimes go across several states. And if you had a block, like just a vanilla block, you end up in this situation, which is pretty common with block, where you have because block gives you one place. You have an input handler or an event handler for each event, and you just have one event handler for all the events, no matter what state you're in. And so block is like a flat state machine, or a flattened hierarchical state machine, if you will. And what ends up happening is inside of each event handler, you end up having all these conditional branches. If I'm in this state, handle the event this way. And that's typical of block, and that's usually fine most of the time. And it got to be for this particular app, because the state management's so complex with the chat experience, it got to be a bottleneck in terms of being able to maintain the code. And so I had figured out that coming from, and this is where it got really interesting, because like doing stuff in like game development projects and coming from that, I was like, Well, I've been doing a lot of that for fun, and hierarchical state machines really do solve a lot of problems where you have branching get out of hand. And as you know, if you have lots of if this, do that branches in your code, it makes it really hard to test because now you have to test each path through your code. And that can explode the number of tests. And I didn't want it to be that hard to test this app, and it also wanted it to be easier to reason about. So I thought, well, maybe I can apply a hierarchical state machine to this project, and I already have block hooked up, so I could use block for the asynchronous part of the flow, and then you have a synchronous state machine that is always the source of truth. And so I kind of came up with this weird pattern where I duct taped a hierarchical state machine to a cubit, actually, not a block. And it ended up being this really beautiful pattern that cleaned up a lot of code. So what happens is now I can have the best of both worlds while I have beautiful asynchronous code that is just await then do this. Without any branching, and it just when it's done, it adds an input to a synchronous state machine, and that state machine synchronously updates its state if it needs to. And now you have this as the source of truth, and then the async stuff just translates into synchronous inputs for the um, state machine, and it was really beautiful, and I was really happy with it. So what that actually looks like in practice is if I go over here to the chat state and we look at our chat qubit, besides the fact it has a lot of dependencies, it extends this little thing called a logic block,
Mhm.
BLOC. And the way this is just a little adapter that I made. All it really does is it owns this thing called a logic block, which comes from this library I created called logic blocks, which is
Mhm.
a port from my C# logic blocks into Dart. This is where the stuff I did, where I stole from Flutter and Dart and brought it to C#. Well, now I'm stealing back from that to bring it back to Dart. So we've come full circle here. Logic Blocks is a library that sort of abstracts some of the complexity that comes with implementing your own hierarchical state machine, or as you might know it, state charts. And state charts were invented as a sort of easy to draw system so that engineers who were creating um, aerospace systems for planes and fighter jets could very quickly reason about behavior in a rigorous way on a whiteboard and be able to draw it, and it mapped to logic very simply. And it was just kind of it came about as a natural abstraction of that. So state charts have been used by, systems engineers for ages now. And they're really useful if you can program them in the state pattern. So this is just kind of glue for that. But basically you can have a logic block, which is just a state chart or an HSM, and then you have a binding to it so that you can listen to things that the state machine wants to do, and we'll get to that in a second. And then we just, for our qubit logic block adapter, you can forward the state of the state machine as the state of the qubit. And that's all this does, really. And then you can add an input to a state machine, which is the same as adding an event to a block. And then you can get data off of this bucket of data called a blackboard, which comes from behavior tree theory, used a lot in game development. So that's what that is. And then basically, when you create your chat qubit, you can listen to outputs, and outputs are things that a state machine wants to do, but doesn't want to be directly coupled to it. So if you're making a state machine and you want to keep it kind of decoupled from the rest of your code, you don't want to make it so that your state machine can know about all of your other systems, because what will happen if you do that is you'll introduce sibling dependencies. That's kind of the trap people fall into when they make a block listen to another block.
Yeah.
Um, and we've all seen that and had to clean that up and advise against that usually. Um, there are valid cases to do that, but they're rare and they're almost never done. In any event, once you have once you have your state machine, you want to keep it decoupled. So a state machine can produce an output anytime it wants, and that output can be listened to by binding to the state machine. And then in our case, we're translating that into kicking off asynchronous operations. And then we'll tell the state machine when we're done with the asynchronous operation. And as far as the state machine is concerned, there's no such thing as an asynchronous operation because it lives in a synchronous world. And that allows it to just always be deterministic and correct. So if we look at this, for example, when you start loading your models, you tell it you tell the state machine and you give it an input that says the total models, there's this many of them.
Mhm.
And then, for all the models that you want to load, you give it an update, an input about where you're at on loading it. And then this is a synchronous operation that is you're awaiting the Cowbrain system to do it, and the Cowbrain has a progress callback, so you can do a progress bar. It wasn't really like working on macOS. It works great on Linux for some reason, and it has to do with Llama CPP. But basically, when you're done loading and you finish this asynchronous operation, you just tell the state machine like, "Oh, I'm done. The model's loaded." And then same thing for these other asynchronous flows. You initialize the brains, which is also an asynchronous operation. You just tell the state machine when you're done. And that keeps it really clean. There's no ifs in here. There's no branching. It's just super simple. And then when you look at, these are all the inputs that the state machine can take. It's pretty straightforward. The state machine, has data that it cares about. And then in the actual unlike a block, because it's hierarchical, each state can have its own input handlers. So when this is the base state, this is just chat state, and it provides basic functionality for all the stuff that the states have in common. But like when you're in the uninitialized state, when you haven't loaded the models yet, it only gets one input, which the start input. And when it does get the input to start, it updates this data on that it shares with the other states, and then it outputs this output that says, "Please load the models. I'm ready now," and then it goes into the initializing state. And so now this state stops being the active state, and this one becomes the active state, and so on. And so that I found this overall flow. I found that to like clean up the chat experience a lot, and that was a very long-winded way of saying that.
No, no, certainly. And I think that this is a pattern that, I mean, I've fallen in the trap of like blocks or qubits, listening to blocks and qubits. And it's one in which like, I'm never happy with the solution. I always kind of like end up like scratching that and trying to figure out like, what can I do on the repository layer? Or can I decouple into different independent things and then like send the message up, send the message down? And I think that this is very elegant. It might even have like a natural place in the block library as a pattern for those complex cases because there's definitely interdependencies there, right? And I think no, no, I'm blown away. That's clever.
Thank you. I can't take any credit other than just making a little tool to implement this, but all the real insight happened decades ago, building fighter jets.
Let me tell you, because I actually like I didn't study computer science. I studied like something called in Spain telecommunications engineering. So to put satellites in orbit and like there's a lot of like procedural things. And this is what I've learned um through very hard moments. Understanding state machines is very easy. It actually very powerful visually, right? Like you can create like diagrams and pretty much like follow the flow. Implementing state machines in code, I don't think anyone has figured out all the edge cases in a very elegant way.
I have spent quite a while implementing state machines in code, and no truer words have been spoken. They are deceptively simple.
Yeah. Well, Joanna, this is awesome. I don't know if you had any other kind of like tips or tidbits that you wanted to share.
I don't think so. I think I covered most of the highlights that I could think of. There's probably no shortage of stuff you could cover.
No, that's pretty good. And of course, like this can be found on GitHub, right?
That's right. It's on my personal profile, which I'm sure folks will be able to find. And they're welcome to contribute to it as well. It's in a pretty good spot.
You know, that's great. And I'm glad actually that you not only created this, but like it helped you to contribute back to other places like Nocturne and things like that. So that's
Right.
we're gonna do a little bit of something special format that I want to try for these episodes that I'm calling a lightning round.
Okay.
You want to stop sharing your screen and just focus on the lightning round. Are you ready?
Happily.
These are gonna be 6 questions. Fire them and answer them without thinking. Let's see where it goes. And I hope it's
Okay.
gonna be fun. Okay, you
All
ready?
right.
Godot or Unity for a brand new indie game in 2026?
I think that's pretty simple because if you think about the PR stunts that Unity got themselves into, they lost a lot of trust in the developer space, and so many developers and companies have been adopting Godot for their newer projects. And I think games take about 5 years to make, so I think in a couple of years you'll start seeing more and more Godot games increase. In fact, there was actually an industry study that came out a while back that shows that Godot, it's the third most popular game engine, right behind the big dogs, Unity and Unreal. But industry usage for it has been doubling year over year, which isn't much, and I'm not entirely sure how they did it, but this was put out by Perforce, which is like the Git, but for game development. And it showed that I think Godot is somewhere around like 15 to 18% industry usage or something. So it's getting up there. So year over year doubling isn't much when you're tiny, but it is growing rapidly.
And even I think with the advent of AI assisted techniques, whether it's Cloud Code or like whatever, right? Like the barrier to build video games, like you like even mentioned like building this project, like, hey, I've been using Cloud Code just to learn and kind of like complete the parts that I didn't know. I've been using it as a secondary brain, as an extra source of knowledge. And I think that there's gonna be a lot of people that are gonna be like, oh, I'm no longer afraid of building a game because I have like an assistant working with me. And of course, that also creates a perfect spot for like open source engines, in this case Godot, to be like, well, you have an open source engine that is free. You can combine it with AI assisted technologies. Build your dreams. Go to Stream Deck or whatever that is. So that's gonna be pretty cool.
Yeah, and I think a lot of companies like that they can customize it without the licensing fees as well.
That's true. Awesome.
Yeah.
Second question: favorite chicken soft package you've built? The one that you're most proud of.
Probably this one called Sync, SYNC, not like kitchen sink. It's not very much code and it's incredibly elegant. And it was really hard to get it that elegant. It's hard to pick favorites though, because I also really like logic blocks as well. But Sync is especially elegant in the sense that it's basically like RX Start and similar systems, but it guarantees deterministic serialization of events, and not the serialization like turning one data into another, but the serialization of guaranteeing that things happen in order. And it protects against what's called reentrancy, where you're in a callback for a binding and you trigger a change and that same binding fires again, and now you've just recursively gone down your listeners. So it protects against that and guarantees that it flattens out into a serialized sequence. And it allows you to use all these different primitives, like I want to listen to an observable list or an observable map or an observable message queue kind of thing. And it was really tricky to get the plumbing just right to where it could do this without allocating a ton of memory. And in C Sharp, that's really important for game development, to be conservative about your memory. So I think that's my favorite because it kicked my butt to make it.
Is the ones that cause the most pain, the ones that we love the most.
Yeah,
And that one can be found on GitHub as well under the Chicken Soft organization, right?
that's right. Yep.
Awesome. All right. Third question: local LLMs or cloud APIs for LLMs? Where do you land for your pet projects and things like that?
I haven't saved myself any money with Cow. It's not useful enough to have saved myself money yet. I'd have to build out quite a lot of tooling around it. I want to believe in a world where local LLMs can do everything, but I was reading some papers, not papers, but just articles that were talking about these papers. And the idea was that the models get better with size and they can solve more problems. And I think it's because all AIs are essentially compressed when you think about how embeddings work and how they turn, everybody knows all this stuff, but they turn the understanding of tokens into this vector field that's multidimensional. And you end up with concepts that are on top of other concepts, and that's what is responsible for a lot of the stochastic nature of things. But as it gets bigger, the concepts become more logically aligned, if you will. And so the quality is just, you got to have those big frontier models to do anything substantial, sadly. But I'm no expert. That's just my what I've read about it.
Probably at our stage, it's fun to read. I gotta say that the math behind it, I find it like crazy.
Yeah.
I would love to pretend that I understand it, I don't anymore. Probably like when I was in college doing algebra, I would have like been able to follow multivectorial dimensions and things like that. Not anymore. But it's fun to read from time to time.
And I think most of us, we're just integrating it. We're not having to build the inference engines, thank goodness.
All right. One thing that you'd steal from the Godot ecosystem and bring it to Flutter.
I can answer the reverse of that.
Okay.
I really like Godot, and as far as game engines go, Godot has a really good UI system, but coming from Flutter, where it's incredible, it still feels like the dark ages. So if I could bring something from Flutter to Godot, I would want to overhaul the UI system yet again. But it's so funny because people coming from like Unity or Unreal to Godot, they're like, this is incredible UI system. And I'm over here just like, not really, but you don't know what
Like
you're missing. Yeah.
sitting in the future with a secret power.
Yeah. So it's easier to answer the reverse of that. I don't know what I would take
I
from
mean,
Godot back.
you were talking like, for example, like these like logic blocks and things like that, things like you've seen in other places working that you needed to bring back to you. Like maybe that not necessarily like Flutter, but I think that that one is a good point as well.
Yeah, I guess bringing the pattern of state machines from game development over into Flutter apps, that's something that can clean up a lot of code for really complex things.
What would you say is the most underrated C# feature that Darts should adopt?
Records. Um, are you familiar with C# records? They're absolutely beautiful.
I've done a little bit of them. I'm not like a big like C# person or anything like that. But like I do remember that there's I think the Dart ecosystem for a while has been lacking like strong like data models and types for like to carry certain types of information. Yeah, records and
They're just so yeah, that's just it, right? So they are data container types. Kotlin has data classes and Swift has, I think, probably some macro for this or whatever, but they're data classes that automatically implement shallow equality for you and hashing. And so in our case, we have to use something like freezed or write copy with by hand and implement equitable by hand, which is error prone. Or you can use our colleague and fellow unicorn Jamie's new package, Crystallis,
Christy.
which yeah, have you heard about this?
No, we should
Okay,
change that with the team later.
yeah, so Jamie's been working on Crystallis, which she just open sourced, and I think it's going to be the one data class package to rule them all, in my opinion.
Yeah, I know that there was a lot of expectation for macros and what that would imply for the Dart community. We know how hard it is also to get it work. But for like probably there's gonna be like intermediate steps. And there are like more dedicated packages that are gonna solve some of those problems. So I'll have to check it out. Crystallis, I'll take note.
I'm actually excited to integrate it into Cow, and I think I have some homework on that because I found a bug in it the other day when I was first attempting to do it. So I was like, "Hey, Jamie, I need you to fix this."
I wanna get Jamie here on the podcast as well. I'm working on it, but like
Cool.
there's a big topic happening right now that is preventing that.
You might have to get her several times. She's got a lot to share.
I know. That's what happens when you're amazing. People just want more of you. All right, awesome. Last question. If cow could be any other animal on the than a cow, which one would it be and why?
It was tempting to call it chicken.
Chicken. Yeah.
Yeah, but I didn't want to conflate the two worlds.
Yeah. Awesome. Well, Joanna, thank you so much. I hope that you had a great experience. I've certainly like learned a lot today, and this has been a lot of fun. For me, one of the biggest takeaways, like first of all, curiosity is great. I think that you decided to embark on a project in which like, like, oh, I don't have all the answers, and that's fine. Probably that's where the fun was. I also appreciate how you are capable of like jumping between technology stacks and all the stuff, right? I think that that's very, very impressive. And like, I know that you inspire a lot of people in our team and outside our team as well, right? So thank you so much. And I'm going to try to book you pending dates and all the stuff, but we need to do a deep dive on Godot as well at some point.
Okay. Well, thank you. I learned from the best, and I was super happy to give this walkthrough. It was a lot of fun.
Awesome. All right, folks, thank you for joining us in Very Good Engineering and see you next time.